This video is going to be based on sequences for the MYP syllabus. We will be coming across three types of sequences. The first one of them is the arithmetic sequence. The main characteristic of an arithmetic sequence is that it gets a common difference. It means this is obtained by adding a fixed value. We will denote the common difference by T. It is obtained by adding a fixed value. This fixed value is called the common difference. And how do you make sure that it is arithmetic? You would always take three consecutive terms. You take three consecutive terms if next minus previous is valid for the two pairs that you make, like 12 minus 9, and is it the same as 9 minus 3, 9 minus 6? Then you have an arithmetic sequence at hand. Okay? And the common difference is simply this value that you get. Now, once that is obtained, you need to generalize. We will be discussing how to generalize that. So the general rule for arithmetic sequence is an equals to a1 plus n minus 1 into t, where d is the common difference, n is the position number. Like what position are you talking about in that sequence? And an is the general term. We also call it the nth term. Like if you're working for the 10th term, so you'll say a10. If it is the second term, you'll say a2. Well, that is more algebraically strong, but if you are just required to generalize an arithmetic sequence, then you just need to go by a shortcut that I want to share with you, which is the an is equal to difference times n plus the zeroth term. Now you don't have the zeroth term here. You just have the first, second, third, and onwards. Okay? What is happening to the first term to get to the second term? First term is increased by 3. Similarly, second term is increased by 3 to get 12. So we know that the common difference is 3. You can see the arrows. If from first to second you have to move by addition of 3, how would you go backwards to find the zeroth term? That will be subtraction. So 6 take away 3 will be, your zeroth term is 3 here. If we fill in this value, we will get the difference is 3n, and the zeroth term is 3 itself, and you've got yourself a general rule. It's that simple of a shortcut. But if let's say if you want to go by the original general formula a1 plus n minus 1 t, then an is equal to a1, which is 6, the first term, and n has to be kept in general because you're finding the general term, and t is 3. You will multiply this 3 with each of the terms inside the bracket separately. So you get 6 plus 3n minus 3. And finally, you've got 3n plus 3 as your general rule. So both of these formulae bring the same general term. It depends. Sometimes it's inevitable to use this. There are situations which I will share right now. Let's say you got a question. You are told that the second term is 9 and the fourth term is 15. Find the 19th term. How would you go about it? Take some time to think on it, and we will come back to this question after the other sequences. So to sum it up, arithmetic sequence is our first type of sequence. It has a common difference. We also say that this is the first difference. You see that the first layer we checked, and it is a constant. Hence, we know that our general term will be a linear sequence, the highest power 1 sequence. Okay? The general term is a1 plus n minus 1. D is the characteristic common difference. It's the fixed value that you get every time you subtract next minus previous. Right, moving on to the next one. And interestingly, it's not the geometric sequence. It is called quadratic sequence. Our next one is quadratic sequence. So we check for the first difference like before. If our first difference is constant, we will say that this is the arithmetic sequence. But let's see what happens here. From 0 to 1, how much is the difference? 1. From 1 to 6, the difference is of 5. The addition of 5 is taking place. And then 15 and 6 have a difference of 9 and then 13. Clearly, our first difference is not constant and hence our general rule will not be linear, just like before. However, we can proceed towards checking the next difference. We call it the second difference. Let's take a look at the second difference. Second difference is you add 4 to 1 to get a 5. You increase 5 by 4 again to get a 9. 9 increased by 4 is 13. So we see that our second difference is constant. We always check for the first difference, then it will be arithmetic sequence. If not, we check for the second difference. If that is constant, we know that we are going to have a quadratic sequence. Now, what's the general term of a quadratic sequence? Can anyone tell me? It is an equals to an squared plus bn plus c. The highest power is 2 and then 2 for the variable n and then it goes decreasing one by one. You can say x as well, but normally we represent the position number by n. So let it be n instead of x. Right. So as soon as we have decided that this is a quadratic sequence and it has the terms a, b, and c, remember you must be very clear about interpreting these ABCs. A is the coefficient of n squared. Coefficient is a constant which is multiplied with a variable. So a is a coefficient of n squared, b is a coefficient of n, and c is a constant term. Since this is introduced by ourselves, our job is to find the values of these unknowns. That's always a rule of mathematics. Whatever variable you introduce by yourself, you have to find its number value using given information. Now you have to follow these 3 steps and in the very sequence that I'm going to share with you, and you'll be able to find all these 3 terms. It's a very simple method. So result number 1. Result number 1 will help you to find the value of A. A is simply the second difference divided by 2. Or in other words, it's the half of second difference. Our second difference here is 4. So the value of A will be 2. I have one of these unknowns found. So my general rule is, at least I know the value of A by now, 2n squared. Let's find the value of B. For B, our result number 2 is to be used. The result number 2 says 3A plus B is equal to second term minus first term. 3A. A is already found to be 2 plus B. Second term here is 1 and first term is 0. So 6 plus B is equal to 1 and that gives me the value of B which is equal to negative 5. Another variable that I gave myself and I've got the value of that. So B is negative 5 and is multiplied with that. The result number 3 is to be result 3 is that the sum of all these ABCs, A plus B plus C, is equal to the first term itself. A is 2, B is negative 5, and C is to be found. And the first term that we have is 0. First, second, third. The first term is 0. Negative 3 plus C is equal to 0, and C is equal to positive 3. All 3 unknowns are done. And that's my general. We have just generalized so far. The other command terms and the other skills that are associated with that, we will share it in a short while. We've got arithmetic sequence. Arithmetic sequence is obtained by having the first difference common, and it will be a linear, that is highest power 1 sequence. If the first difference is not constant, we will check for the second difference. If that is a constant, then we know it's a quadratic sequence, and the general form will be a squared plus bn plus c. We will find these a, b, c unknowns by these following results in the specific order. A is half of second difference, B 3a plus b is second term minus first term, and the result number 3 is sum of a, b, and c is the first term. Once all these values are found, you will plug in into this general formula. Again, an is the nth term and n is the position number. All right, the next one is slightly different from the linear one. We call it geometric sequence. You know what the characteristic of this type of sequence is? That instead of adding a fixed value, something is multiplied. You see what's happening here? 4 is multiplied with 2 to get 8. 8 is multiplied with 2 to get 16, and so forth. Just for a better discussion, I'm going to erase 4 from our sequence. So our first term is now 8. Let's start the sequence with 8, and we will have a better discussion, I believe. 1, 2, 3. That's the first term, second term, and third. For a geometric sequence, the characteristic is that it is obtained by multiplying a fixed value. In arithmetic, we add a fixed value, and in geometric, we multiply by a fixed value. That fixed value is called common ratio. And how do you find the common ratio? You take 3 consecutive terms, just like before in the arithmetic. You take 3 consecutive terms, and you find the ratio by next over previous. This time division is involved. Next over previous. Okay, so in this case, let's see our ratio. What's the ratio here? 32 divided by 16. If that's the same as 16 over 8, then we know that we have a geometric sequence. In this case, the common ratio is 2. Now, as before for arithmetic sequence, the general sum of geometric sequence is given by an equals to a1 r to the power n minus 1, where a1 is the first term, r is the ratio, n is the position number. Here, a1 is equal to 8. You see that first term? The ratio is this 2 that we have just figured out, and this will be our general rule. You may want to keep the general rule up till this point, but let's just use a few of the laws of indices. You remember a times a to the power m times a to the power n. What happens? Would they be added? A to the power m plus n. Similarly, if you have a power n, a power m divided by a power n, then you'll have a difference of these powers. So I see a difference of these powers. Can I write 2 power n divided by 2 power 1? And I don't show the 1 in power, of course. That can be further simplified. 2 1s and 2 4s. That's 4 times 2 power n. If you still want to write it in another form, you may still. 4 is 2 squared, and this is finally 2 to the power n plus 2. These are all possible forms of the same correct general rule. Yes. Okay, so this is the we call it the more orthodox manner of finding the general term of a geometric sequence. But we have a shortcut as well. Just like before, Uh, what's the zeroth term here? If you're multiplying by 2 from left to right, from 8 to 16, what would you do in the opposite direction? You divide by 2, and 8 divided by 2 will be 4. Okay, so what you do is your general term is the zeroth term times ratio to the power n. This is your little hack here for the geometric sequence. What's your zeroth term? 4. The ratio is 2, and that's it. You see this is already there. You want to further simplify that, and you can write 2 to the power n plus 2. So far, what we have done is the three sequences. First, we did arithmetic. It's obtained by adding a fixed value. Then we did quadratic. If the first difference is not constant, we can check for the second difference. If that is constant, then it will be quadratic. And then we did geometric sequence. This is obtained by multiplying a fixed value. If I were to continue this, let's say if I don't get the second difference constant even, what about third difference? Let's say if we continue to go through the third sequence. You know what will be the highest power of our general term in that case? If the second difference is constant, our highest power of the general rule is 2. Let's say the third difference is constant, then our general sequence will be a cubic sequence. It'll have highest power 3. Not in your syllabus though, but this is how it progresses. All right. Now, once these sequences are done, we know how to find the sequence just from number values, of course. There will be difficult situations. I'll definitely discuss in some other video. But once all these generalizations are made, what is our next job? Our next job is once you generalize, then you have to do two checks. Number one is test your general rule. And number two will be verify your general rule. And number three will be justify. Sometimes the word prove and derive are also associated with the same. So we this is the top level for MYP 5. Justification is the highest strand involved. Now, how do you test? For test, which values do you use? You always use the given values. Don't say first three terms or first four terms or first two. Whatever number of terms they have already given, you use those given values, then you are doing testing. Also important to note is you have to announce that you're testing. You just can't do the plug in the values and without any announcement, you just don't use the values there. You have to announce that I'm going to test, and for test, you use given values. If your general rule gives the same values, then you say that my rule is correct. In short, you put up some sort of a claim, a statement that your general rule is the same as your general rule is giving the same values as you have in the table, right? Or in the list here. Now, if looking at this sequence, how many values are my given? First three terms. So if I'm using first three terms, I will be doing testing. Let's say I predict the next ones, which are 15, 18, and so forth. Let's say I predicted these two. Then using these values will be accounted for verification. Okay. It's a very simple analogy to remember. When you take your blood tests, what happens? You're given your values in the blood test against the normal authentic values. So the values which are given by the examiner, they are considered authentic. If you're comparing with the authentic values, that is called a test. If you're comparing it with the values that you predicted, we will be calling it verification. So for verification, you use predicted values. And again, don't forget to put the claim. Claim can be in any form. You can simply state which gives the same values as in the table, which gives the same values as predicted in any form, you have to put up some sort of a claim here. Now, justification is a high-end command term. For justification, you should go to the context. Usually, it's a geometrical context from where you derive the general rule. Okay, not just looking at the numbers, but actually, let's say these are area of something. Okay, or this is the perimeter of some shapes, a growing pattern. If the perimeter is changing as 6, 9, 12, and so forth, or the number of sides of some uh, growing pattern there is, then you have to derive that general rule from there. I know it's quite an abstract sort of thing at the moment, but in later discussions, we will definitely come across the command term justification in a bit more detail. Before generalization, what were you doing? You were predicting the values and you were asked to describe in words. Describe means write in words whatever pattern you observe. So for criteria B, which is investigating patterns, in your syllabus, this is pretty much your line of study. You should know how to describe, you should know how to predict, generalize. Once you've done generalization, then you test, verify, and justify your general. For description, remember saying just arithmetic, just quadratic, just geometric is not good enough. If you're saying arithmetic, you will have to say that this is arithmetic with a common difference of two. If you're saying geometric, then it has to be a geometric with a common ratio. If it is quadratic, it is quadratic with a second difference, whatever that is. Okay, just arithmetic, geometric, or quadratic won't give you marks or credit for description. So far, this is our discussion. Okay, I want you to test this rule. So if I were to test, I've got the general rule 3n plus 3. I want to test so I can use any of the first three values. Let's say I use the third value. Here, n equals to 3. So I'll plug n equals to 3 here plus 3. Do I get 9 plus 3, 12? Is it the same as listed and it's the same from my formula? It means my general rule is correct. Another precaution is that you have to use the same variables as given. Let's say we have a, a scenario where we were given some matchsticks and some figures. Let's say figure number F and number of matchsticks. Number of matchsticks. You are going to write a general rule for matchsticks. Let's say this is 3F plus 1. Clearly, that n that we use to practice a lot for our general rules is there no more. We are not writing n anywhere. We are also not writing an. We have to use the same variables as given. That's precaution number 1. Please write it down. Precaution number 1 is to use the same variables as given. Use the given variables, not necessarily m or n or an. And then precaution number 2 is also an interesting one. When you're asked to generalize, a general rule must be an equation. Must be an equation, yes. Like you see, this is my general rule. M is equal to 3F plus 1. Why is it a general rule? Because I have written M equals to 3F plus 1. I've expressed one variable M in terms of the other variable M. It must be an equation. So if you write 3F plus 1, you do not get full marks for generalization. If it is 4 marks for generalization, definitely you will get 3 marks because you are yet to write the relationship between the two variables concerned. Okay, 3F plus 1 is nothing in itself unless you say that the number of matches is equal to 3 times the figure number plus 1. I will also take this opportunity to list another precaution. The precaution is when you write description, don't just read the general rule. That's also a mistake that has been observed. It's funny, sort of funny, but let's say my general rule is m equals to 3f plus 1. And in the description part, if you're asked to describe, you say it's 3 times f plus 1. It's not considered at all. It's not a description. Okay. The better descriptions are, if I were to state here, for this general rule, it's addition of 3, it increases by 3, it has a difference of 3, and in most particular and appropriate manner, this is arithmetic sequence with common difference t. That's the best one. Sometimes the examiner asks you to describe it more than 2 ways, or let's say more than 1 way at least. So you should be able to describe the same thing, same pattern in 2 ways. One way could be increases by 3, and the other way is it's an arithmetic sequence with a common difference t, a common difference of 3, right?